This is me racing the AI I have been training for the past 2 weeks. And this is when I first started training. This is Barry, and he's going to learn how to race. But it wasn't as easy as I had planned. It took many hours, $7 in AWS credits, and a lot of hope. Teaching Barry was like teaching a toddler, except the toddler had 13 laser eyes. Alright, to teach an AI how to race, we need to give it a car, a track, and a brain. So here's what we're building. A 2D racing game in Pygame, simple graphics, but the track, honestly, pretty challenging. 18 turns, and I can lap it in around 24.5 seconds on a good run. The goal, train an AI agent that can beat this time. So first, making the game was pretty easy. I went to Pygame documentation, Ctrl+C, Ctrl+V, and we have a window. Then I made a beautiful car, let it move. So I made it move. Then I refreshed some high school math, and now it can also turn. So next, the track is based on an F1 track, but I'll let you figure out which one. Here's a hint, my game kind of has a flat version of this track, but leave your guess in the comments. Okay, so right now the car is not really carring, so let's fix that. Now it accelerates properly and can make turns at a high speed. Perfect, let's set some laps. So my best was 34.5 seconds. This will be the benchmark for Barry. So I started with Approximate Q-Learning. If you're not familiar, Q-Learning is basically teaching an AI through trial and error. The agent tries stuff, gets rewards for good actions, penalties for bad ones, and slowly figures out what works. Think of it like training a dog, except instead of treats, it's getting numbers, and instead of a dog, it's math. I gave it 7 ray casts, shooting out from the car, basically laser beams that measure distance to the track boundaries. I also gave it velocity and heading direction, so here's what the AI sees in the game. The reward system seemed pretty simple enough. Reach the next checkpoint tile and get a reward. Drive on the grass, get a penalty. So Barry is ready to ride. I let it run overnight on my laptop, and I woke up excited to see my AI prodigy taking clean racing lines, maybe even posting some competitive lap times. Instead, I got this. It had learned a local optimal strategy of immediate self-destruction. Every single time, like some kind of digital death wish. Turns out my reward system makes him feel bad. Yeah, I discovered that crushing and resetting was better than trying to navigate the track. Incredible. I've made an AI lose his will to live. So I tweaked the rewards, then tweaked again and again. Different penalties for grass, rewards for maintaining speed, bonuses for check progression. I was basically a game designer, trying to convince an AI that living was worthwhile. But Approximate Q-Learning just wasn't getting it. The stage space was too large, the track too complex. After dozens of training runs, it could maybe handle the first 3 turns before turning into a lawnmower. Time for the big guns, deep Q networks. So DQN is basically Q-Learning on steroids. Q-Learning has a linear function guessing the best action. DQN uses neural networks, which is way cooler. But here's where I got clever, or at least I think I did. Instead of training one AI at a time, what if I ran multiple cars simultaneously, all learning from the same model? More attempts per second, more diverse experiences, faster learning. It's like instead of one student studying alone, you've got a whole classroom sharing notes. Plus, it is way more interesting for my monkey brain. Now, I couldn't keep my laptop running 24/7 without turning it into a fire hazard, so I spun up a virtual machine and I streamed the training to Twitch. Yeah, I was that guy streaming AI to train. And it was learned, slowly, very slowly. After hours of training, it made it to turn 6. Turn 6 out of the 80. At this rate, my grandkids would be the ones watching it complete the lap. So I did what any reasonable person does when their approach isn't working, try something completely different. Enter PPO, Proximal Policy Optimization. PPO is more modern, supposedly more stable, and it's used by OpenAI for a lot of their robotics stuff. It uses policy gradient methods instead of value-based learning, all very fancy. It was also very slow and very bad at this specific task. I did not hesitate to switch back to DQN. So I went to my GitHub commit history and I copy pasted it back to DQN, but this time I was going to fix the real problem. My reward system is trash. To understand the new system, think of it like a GPS navigation. The old system only told you when you arrived. The new system should constantly tell you if you're getting warmer or colder. So I added waypoints at every corner. These are invisible checkpoints. Well, I made them visible here, but they give the AI continuous feedback about whether it is getting closer or not. So way more information, way more opportunities to learn what is good driving. And I disabled that VM because it was eating my free cloud credits faster than Barry loses his will to live. Back to the laptop. And then it happened. 7 minutes and 12 seconds. It completed a lap, a full lap. All 18 turns. Was it slower than a grandmother on a Sunday drive? Absolutely. But it completed the track. I have to add, at this point, Barry was still driving 60% randomly. So I was really happy, doing my best dance moves, and then it crashed my game. A lovely little bug that I hadn't noticed because the AI just didn't get this far before. Suffering from success. Anticlimactic? Maybe, but I fixed the bug and we were back. I gave it some more time and the lap times actually started dropping. 7 minutes became 5, 5 became 3, and then 1 minute 53 seconds. We're in the level of actually kind of decent, not good, not near beating me, but decent. And then something weird happened. It stopped completing laps entirely. Barry wasn't exploring anymore, just exploiting what it knew. And what it thought it knew was apparently a worse policy than before. This is the AI training equivalent of confidently forgetting how to ride a bike. Or in this case, a car. But I didn't spend a week on this, just to give up because the robot had an identity crisis. New approach, 10 cars total, forecasts stay at consistent epsilon values. So the epsilon value actually decides how random they act. And so these 4 cars, they will keep exploring forever and always bring new experiences. The other 6 cars, they use epsilon decay, so they gradually get more consistent. It's like having veteran drivers who are still trying weird lines mixed with rookies who are slowly figuring out what works. The results? Well, it got really close. 34.5 is the benchmark and it reached 36 seconds. After which Barry again forgot how to do laps again, because he just learns and then unlearns constantly. So then it was time for Max Verstappen of Q-Learning, Rainbow DQN. This is from a paper from DeepMind of Google. They combined 6 improvements to make the best student you could want. I used 5 of these improvements. So Barry just got a massive upgrade. Also gave me some more race. You never know if this helps. I let it run and the results were insane. 2 weeks of work trying to teach Barry how to race, and here he is, consistently doing laps and actually beating my time. Which brings us to the fun part. 1 human, 1 AI, 1 track. Let's see who is faster, the master or the student. Are you kidding me? It actually did it. The thing I built to beat me actually beat me. I'm kind of proud and also slightly concerned about my job security. This whole project took a little over 2 weeks and probably 60 plus hours of training time, multiple algorithms, countless tweaks, and more laptop fan noise than any human should endure. But watching this AI go from suicidal to competitive, completely worth it. If you want to see more AI learning stuff, me and Barry still have plenty of learning to do. The subscribe button is down there. Also, don't forget to give a like for Barry's accomplishment. And thanks for watching. Now, if you'll excuse me, I have some training to do.